Hi, my name is Avery Ash, and for this week's interactive case study, we are talking about penicillin. Penicillin is an antibiotic that's used to treat a number of bacterial infections. It's effective because it targets bacteria-specific proteins, but it leaves human-specific proteins alone. Penicillin does not work for every bacterial infection, and it works best against gram-positive bacteria. Penicillin's purpose is to stop newly divided bacteria from forming a cell wall, and this causes the new cells to burst, which prevents the proliferation of the infection. Penicillin targets its target protein by mimicking acyl D-alanine D-alanine. This inhibits the enzyme transpeptidase, which is what cross-links peptidoglycans in the cell wall. And the permeability of the cell membrane is increased because the cell wall is full with holes, and this allows uncontrolled flow of solutes into the cell, which then leads to it bursting. Here's a picture of the comparison of this is the alanine, D-alanine, and penicillin. And if you look at the positioning of the oxygens, it's similar. And also this one, nitrogen is also in a similar space. And this allows penicillin to attach where D-alanine, D-alanine normally would. And then this is a visual of it in action. Here we have transpeptidase is creating cell wall. It's binding these two molecules together. But then penicillin comes in and it blocks the transpeptidase so that it can't continue building the cell wall. So penicillin only works on gram-positive bacteria. This is because gram-negative bacteria have a lipopolysaccharide and a protein layer that surrounds the peptidoglycan layer of the cell wall. And the penicillin isn't able to get through this, so it can't poke the holes in the cell wall. Penicillin resistance has been increasing due to bacterial evolution. There's a lot more penicillin-resistant bacteria now back than there was back in 1928 when penicillin was first discovered. Some bacteria are able to produce enzymes, which are penicillinases, that can degrade penicillin. Some bacteria can alter their peptidoglycan layer or their penicillin-binding proteins to prevent penicillin from attaching and doing its job. And some bacteria have developed systems to remove penicillin from the cell. This is my one source that I used, and I'm going to move over to Chimera here. I finally figured it out this week. So here we have 4 proteins with penicillin bound to them. I'm going to zoom in on this red one. And here you can see this hexagonal ring is characteristic of penicillin. Those are, you can see where I have a, oops. So here you can see where it's binding to the protein. Actually, I have on this blue one here, I've already went and hid the non-penicillin. Okay. I'm just going to hide the ribbon. I can't see the ribbon. Okay, there you are. I can actually see it. Okay, this is what penicillin looks like. I wanted to show you where it bonds, but I just can't deal with that ribbon. So you can't see anything. But yes, this is what penicillin looks like. We got red oxygen, the blue is nitrogen, and this yellow piece is sulfur. And it is able to attach in place of alanine, D-alanine. and kill bacteria. Yeah, this is interesting. Thanks for watching. Have a good night.